Okay, good morning,นะครับ everyone. So today we are going to talk about module number 1 นะครับ That is the first module for this basic math class นะครับ In this module, what are we going to learn? We will learn about sets นะครับ properties of real number นะครับ operations in the real number นะครับ fractions and decimals. Then I'll talk about the simplifying of the expression, exponents, radicals, and then I'll end up with the absolute values that I apply to the real numbers that we have to study. Now let's begin with the real numbers. When we talk about the set of the real number, we have to talk about the set of the real number. When we talk about set of real number, the keyword or the key terms that I want to talk about is about the set. When we talk about set, set is a collection of objects. For example, suppose you say that you go to buy a New Year present for your friend, and then you can see that in a box. Say that it's a set of 3 marks. So you can see that in this example, this is on the box. It said that set of 3. So in here it's set of 3 marks. In here, this is the collection of objects, and objects in this example is a mark that you buy as a gift. So when we talk about the geometry, when we talk about a line here, we say that we can just like see this one, a line is a set. And you can see that actually a line comes from many dots or many points continuing to each other. If you zoom in here, you see that there are a lot of dots here. So elements in this set is the point. So that means there will be just like infinity points in the line set like this. So in order to specify a set, we have to use the roster notation. Roster notation in here, we just use the rest. And in here we specify the elements inside. For example, if we say that it's a set of odd numbers. And inside we also have like more elements inside here. So this set is an example of the roster notation of the odd number here. So when we say that we would like to have the set builder notation, we build a set by describing what is in it. For example, if we would like to find out the set of even numbers between 5 to 11, what is even numbers? Can somebody tell me? Even numbers? 2, 6, 8, something like that, right? That is divisible by 2. That is the even numbers. So if you know that, you have to find out the set of even number between 5 to 11. What are the elements inside? Can somebody tell me? 6, 8, 10. Anything else? No. Because 11 is not divisible by 2, right? So it's not the even number. So this is the set of even numbers between 5 and 11. Suppose we say that and put it set 8. This is set of even number between 5 to 11. Now, let's continue. When we talk about a membership in a set, a membership in a set here, it's denoted by the symbol here. Can somebody tell me how do we call this one? E. It looks similar to E, right? but actually this is a Greek letter. The thing like this, we call it as epsilon. We denote the membership by using epsilon. Suppose we say that, okay, we have set B, consists of the member A, B, and C like this. We can say that small letter A is a member of set B by using epsilon symbol here. On the other way around, when we talk about non-membership in the set, we use epsilon. But the epsilon, we just use, we have the cross for the epsilon cross like this. We call it as non-membership. So in this example, if we still have set B, we still have set B like this, you can see that small letter B is not a member of set B, because you can see that if you have a loop, there is no dot inside the set, right? So that's why we say that small letter b is not a member of set B. Set A is said to be a subset of set B. We write it down as capital letter C, and then we have just a small line. So in this one, we write down that set A is a subset of set B. When can we define that set A is a subset of set B? If and only if every element of set A is also an element of set B. So if I just give an example, you can see that right now. So whenever you have to just write down set A, that is the subset of set B. In this one, you can see that the definition is that when every element of A is also the element of set B. For example, A is a set of small letter A. This one, you can see that A is a subset. Set A is a subset of set B because you can see that you can find small letter A. Next, if A equals to the set of small letter A and B, here set A is also a subset of set B too, because set B, you can see that for set B it has A, B, and C, and set A you have A and B, and A and B is a part of set B. So that's why in this one it is subset of set B. Okay. Next, if we have A, that is a set of member B and C. This one is also similar to the previous set A, because B and C is a member of set B as well. Next, if set A has a member of A and C, the same thing, A is a subset of set B. And this one, if you have a member A and B, set A, is set A a subset of set B or not? No, why not? What's wrong with this? Which one or what value may set A not to be subset of set B? B. because we don't have B in set B, right? What about this? If you have set A, that is A, B, and C. Can set A be a subset of set B? Yes or no? The answer is yes, because this one you have to refer to the definition. In the definition, it said that if and only if every element of A is also an element of B. Is small a an element in B? Yes. Is B boy, small letter B, an element in set B? Yes. Same as small letter C. So this one matches with the definition. So that's why set A is also a subset of set in this one. Okay, any questions about this example? If no, let's move on to the next one. Sorry, I have to use microphone, otherwise the voice will not come into the video for you. Okay. Now, when we talk about the sets, the important sets that you have to know in this class, we talk about various sets that you normally use in everyday life. Firstly, when we talk about natural numbers, set of natural numbers are the sets that you start with one, two, three, and so on. This is natural numbers. Next, the whole number. The whole number is similar to natural number, but we also have number 0 in there as well. In here, somebody call it as counting numbers. Counting numbers and whole numbers, the same thing. Okay. Integers. Integers are the numbers without any decimal points. So integer I, you have the value from negative infinity. I should just use this term. So this one are all the numbers, are all the integers numbers, including negative integers, including 0, and including positive integers. While positive integer, set of positive integers, we may use I plus equals to 1, 2, 3, 4, and so on. That's a positive numbers, positive integers only. While the negative integers is a set of the value that are all negative. So when you just get the idea of these sets already, you have to know the properties of each set as well. There are some important things that you have to know, some notations that we have to use about the set as well. So that when you have to apply the properties for these sets, you know that, okay, you have to use this one. The next set of numbers that you should know นะครับ is what we call rational numbers นะครับ when we talk about rational numbers this group of numbers นะครับ or this set consists of numbers that can be written as quotient of integers นะครับ for example if you say that 1/2 นะครับ negative 5/3 นะครับ negative 8/3 these are all the members in the rational numbers นะครับ okay these are all example of the rational numbers so these numbers you can see that if I have to just like write down every single rational number in the set it is not possible because there will be so many numbers then we use another notation instead that I'll just like teach you later okay so but I just like give you some example of the rational numbers so when we talk about the rational numbers in here all rational numbers can be represented by the first one decimal numbers that terminate for example 3/4 can somebody tell me if we just divide 3/4 what value do we get in terms of decimal numbers 3/4 0.75 are there anything after 5 no you may say that okay it's 0.75000 actually you may say that oh it's not terminated no 0 behind the decimal points behind the numbers like this we exclude it so this one is just 0.75 only this is the decimal numbers that can terminate 0.75 okay next we talk about non-terminating repeating decimal numbers so in this one for the non-terminating repeating decimal numbers means that when you divide the quotients you get a decimal numbers that is not ended for example in this one it said that composed of a group of digits that repeat without ends for example 2/3 can somebody tell me when you divide 2 by 3 what value do you get 2/3 0.66666 this is not the non-terminating repeating decimal numbers and what about 22/7 22/7 is the value of what of we learned it before when we were young pi right 22/7 you get what value remember what is the pi value 3.14159 and so on is non-terminating as well okay so for the properties of the value like this we call it as non-terminating repeating decimal numbers okay so these two examples are the example of the rational numbers we can have like both decimal numbers that terminate and non-terminating repeating decimal numbers in the set of rational numbers as well the next thing when we talk about the rational number already there is another set this is a set that is called irrational numbers for the set of irrational numbers is different from rational number if you remember the rational number it is the numbers that you can write down in the quotient of the integers but irrational numbers are set of numbers that cannot be represented as ratio of two integers so if you see that okay there are some numbers that are not the that cannot be written as ratio of two integers we call it as irrational numbers Irrational numbers can be represented by non-terminating, non-repeating decimals. Together, when you have two sets together and have set of rational numbers and set of irrational number, when you combine these two sets together, it forms the set of real numbers. In this class, we use, when you calculate anything, you will get the solution only when the answer is in the real number. For example, if you have something like x equals to 5/5 like this. 5/5, you can further simplify. 5/5 is 1, right? 1 is the integer, right? Integer is a kind of rational number because you can represent it in terms of the fraction between two decimal is 1/1 like this. So this one is rational number and it is real number. Let's see another example. If I have y equals to 5/0, this one, you can see that even though 5 is integer, 0 is integer, right? But you cannot divide 5 by 0. The answer for this one is actually for that imaginary number. Imaginary number is not a part of real number. So everyone, be careful when you answer in the exam and when you solve, let's say you solve an equation and you get this value, don't answer. You have to say that, okay, the answer of y is not in the real number. Because if you write down 5/0 like this, no one knows that whether it is the real number or not. So that's why this one is not real number. Or you may write down that y doesn't have solution. The next thing, okay, when we talk about the real numbers already, sorry, I just want you to do this. So everyone, I give you 3 minutes. Please solve this one by yourself. Then I ask some of you to help answering this for me. I'm checking the attendance while you are doing this. Augustine no. Sharif Tarasit Anya Tenamtip Alexandra Suphanat Anyamani Yanin Anchita Sahapat Niti Pantapon Tetsu Nichanan Orapim Virashat Thanaporn Thirapat Natchapat not here Kamolapat not here Warisa Warinthon Parkin Peshin Atipat Anybody else hasn't got your name called? All right. All right. Okay. So let's see what time. How long do we have left? Okay, time's up. Okay, so right now, okay, let's see. Who can help me answer this? This one belongs. Anya, for question number 1, what is the answer? One, yeah. What is the answer on the right hand side? Sorry, C. Is that correct, everyone? C, that's correct. Natural numbers. Start from number 1, 2, 3, 4, 5. That are just like the numbers that we use in everyday's life. It is the integer numbers. Okay, positive ones. Just hang on. Next, 10 tip ครับ yeah question 2 ครับ B right whole number is similar to natural numbers but one thing that is different is 0 right A is that correct yes that's correct นะครับ now number 3 นะครับ Alexandra oh sorry not here Suphanat ครับ yeah number 3 ครับ A number 3 นะครับ integers นะครับ come from the combination of negative and positive integers is that correct ครับ everyone choice A yeah that's correct นะครับ choice A the next one นะครับ the next one for question number 4 Yanin ครับ 4 is the dog, right? This one. Right. This one, right? So let's see, rational numbers. When we talk about a set of rational numbers, it is opposite to irrational number, right? Okay, because rational number are the number that you can just like make it to be two integers divided each other as a fraction. So it said that okay, or x is an irrational number. Sorry, this part is the what should be the correct answer? The answer is F is F นะครับ is F. Why is that ครับ When we write down นะครับ the set of rational number let me explain. So P over Q, this is a quotient, right? When Q is a member of Z, Z is integer. Q is integer, yeah. And Q is not equal to 0. Q is not a member of 0. That means Q cannot be number 0. Because otherwise it will not be part of the real number. And rational numbers are part of real number. So that's fine. If you divide any numbers by 0, it is not a part of real number as I told you that it is the natural number. So that's why this one is the notation of rational numbers that we can represent it by using the variables like this. So in this example, in this question, the answer goes to choice F for question 4. Now, question 5 ครับ อัญชิตาครับ E, okay, is E, okay. Is that correct, everyone? E, okay. E is correct. Y is correct. In this one, said that, okay, X, irrational number is a set of X where X cannot be represented as a quotient of two integers. Yeah, this one is the matching definition for the irrational numbers. Now, let's move on to the last one. Real numbers ครับ สหพัฒน์ครับ D dog, right? Okay, is the dog in here? X, where X is a rational number or X is an irrational number. You can see that I just like mentioned in the previous slide that a real number come from the combination of two sets, rational and irrational. So these are just like the way that we use in order to represent the set of different numbers. Okay, any question for this slide, everyone? Okay, if no, okay, if no, let's move on to the next slide. For the next slide, we have 5 questions altogether. 5 example altogether. I give you 4 minutes to do that. I give you 4 minutes to do that. Let me assign the name of the students to help doing this. So for the first one, I want Niti to do that. second one วันทพล third one เพชรสุด fourth one นิชานันท์ and the last one อรพิมครับ okay you have 4 minutes to do นะครับ just take your time the rest of you please do it as well นะครับ so if you finish already นะครับ you may just like go to have the restroom break นะครับ we will continue the class at 11 o'clock นะครับ and for the student whose name is on the screen นะครับ if you finish you can just like go to have a short break and then just like write the answer down on the whiteboard นะครับ you can use alcohol spray if you want to โ so everybody can have a short break นะครับ we will continue at 11 o'clock11ครับ So Close the door. Okay, everyone, welcome back. So now we are going to see how you guys just answer these problems here. You can see that for the first example, set of a whole number that is less than 8. Set of whole number. Whole number is the number that is that are like the integer that start from 0, right? So that is 0, 1, 2, 3, 4, 5, 6, 7. Okay, now let's see the condition. The condition in here. The condition in here said that okay, we would like the set that is less than 8. Less than 8 means that we have to exclude 8 from our set, right? That's why this one we have from 0, 1, 2, 4, 5, 6, and then at 7. This is correct. Next, for number 2, we said that set of integer. Now it's integer as well, but it's greater than 3 and less than or equal to 5. Less than or equal to 5. When we use less than or equal to 5, that means we include 5 in our consideration as well. So greater than 3, that is 4. Yeah. Less than or equal to 5 is 5. So it's set of 2 members, 4 and 5. This is correct. Now, question number 3. You can see that in this one, let's try to think of the numbers that can be in this set. The problem for real number set is that you cannot list out all the numbers because it's so many numbers. Like this one, when you have a line, if I ask you that how many lines are there, right? So that's why this one, okay, he tried his best to add just like the value that is less than more than 2 and less than 3, and then more than 3, and then pi is 3.14 something until infinity for this set. But anyway, even we try our best, if we have to list out all the members like this in the real number set, it is impossible. In this one, when we want to have a set of real numbers greater than 2, the way in order to represent this set, you have to use this notation instead of listing out all the numbers. Okay, we have to assume that okay, we talk about this set. It is like if we have member set, when set is greater than 2, whereby set is the member of real number. This is to represent this set in question number 2. For example number 4, example number 4, set of real number that is greater than or equal to 4 and less than 7. This one is difficult to because when you have to list out all the possible members in the real number, can't do that. So that's why you also have to use a notation that is similar to this one as well. Okay. Suppose I assume that I use small letter a as a member in this set. So I'll say that set A is as what we started. A is the set of the member A. Where 4 is less than or equal to A. And A is less than or equal to 7. Oh, sorry, less than 7. Whereby A is the member of real number sets. So let's see, what about 4, 5, and 6? These are integers only. we still lack of other numbers that are not integers in this set. Because this set number 4, is set that set of real numbers, right? So that's why you cannot use this one. This one is also cannot use. Otherwise, A is not completed. The last one. For the last question, it said that set of even numbers. Okay, you can write like this: 2, 4, 6, 8, 10. Like this. So this is the standard one that everybody knows. This one is okay too. When you study more, I think around chapter 4 or chapter 5, you talk about this notation once again. And at that time, you'll be ready to know that if I try to represent the set of even number, how to memorize it. Because you have to just use some equivalents to explain this. Okay, any questions about these examples? You did very good job, Nahab. I see that many of you try to have the good try in order to just do it. That's good, Nahab. Okay, then if you don't have any questions, Nahab, let's move on to the next slide. On the next slide, Nahab. Okay, the first one. A equals to A is a set of X, where X is an even prime number. Even prime number. Can somebody tell me what is prime number? Prime number. What is prime number? Can somebody tell me? Almost correct, but we have some more precise definition of this. One easy thing that everybody can notice, if it is a prime number, for sure, it must be integer. Okay. But not every integer can be prime number. So prime numbers are the integers that can be divided by 2 numbers. First, 1. Second one, itself. This is prime. For example, if we talk about 1, is 1 a prime number? Let's check. Is 1 is divided is divisible dividable by 1, right? 1 over 1 is okay, isn't it? 1 over itself, and itself is 1, so 1 is prime number. Okay. Next, hang on. Prime number except number 1. Sorry, prime number except number 1. Because anyway, if you just try to apply these properties to 1, it goes to that one. Hang on. For this question, sorry, 1 is also included. Is 2 a prime number? Is 2 divisible by 1? Yes. Is 2 divided by itself? Yeah. And when you divide by itself, you get the integer as the answer. Then it's the prime number. Okay. So 2 is the prime number. 3. 3 is divisible by 1. Yes. 3 is divisible by 3 and get just like the integer as the answer. 3 over 3 is 1. Yeah. 4. 4 divided by 4. Even though it is divisible, but can 4 be divided by 2 and get the integer as the result, right? So 4 is not prime number. 5 Can 5 be divisible by 1? Yes. Can 5 be divisible by 2? No. By 3? No. By 4? No. By 5? Yes. So 5 is prime number. Is 6 a prime number? No, because 6 can be divided by 2 or by 3 or by 1. 7? Yes. 8? No. 9? No. 10? No. 11? Yes. What is about this set? Yeah, okay. In this one, you can just like write down the set of this one as like this. It said that even prime number. The even prime number. So you can see that, okay, there is only one value. There is only one value that is even number. What is it? 2. So this set even prime number is 2. So what about the next one? The next example, B is a set of x, where x is greater than 50, and x is greater than 50, and x is less than 60, and x is a prime number. X is a prime number. So that means the value for x here is between 50 and 60. That means we exclude 50 and 60 from our consideration, and x must be a prime number too. So everyone do it by yourself. Tell me, what is the answer of this set? I give you 1 minute to think about it, and I would like to have someone to just like tell me what is the answer for this set B. Five seconds left. Time's up. Okay. So what is the answer? 53, 59. Is that all? 53 and 59, right? Okay, now let's see. When you are asked to find a prime number, firstly, all the numbers must be integer for sure, right? Okay. So let me list up first. We have possible value from 51, 52, 53, 54, 55, 56, 57, 58, and 59, right? Because these are the integers between 50 and 60. So, is 51 divisible by other number except 1 itself? 51 can be divided by what number? 3. So 51 is not included in this set. 52, 2. 53, no. 54, 2. 3. 27, 55, 5, 11, 56, 2, 4, 28, 57, 3. And 19 as well. No. 58, 4, 2, 28. Then we have 59. No, that's like one in itself. 53 and 59. That is correct. 53 and 59 is a prime number between 50 and 60. That's correct. Good job. Okay. Next. This one, please do it by yourself. I give you 3 minutes to do this one. I give you 3 minutes to do this one. And then I'll let some of you to answer this for me, please. When you answer, not just true or false, tell me to why it's true or why it's false. Okay, time's up, everyone. Time's up. So, Pirachat, is negative 13 is an integer? Yes, right. Why? What kind of integer it is? We have 2 different kinds. Pardon me? Yes, that's right. Negative 13 is a member of negative integer. That's right. So this one is true. Next, Thanaporn, is negative 3 is a positive integer, true or false? False. Why is that? So positive integers start from what number? 1, right? This is negative 3. It's not in the positive integer set. Yeah, so the answer is false. So number 3, Thirapat, square root 3. False. Why is that? Why square root 3 is not a rational? You're not sure? When you see this one, and it's asked for some definition, you have to go back to see the definition first. What is the rational number? What is the rational number? So when you go back to see the rational number, it's in here. Rational number consists of 2 numbers. That can be written as quotient of 2 integers, right? In this one, it said that quotient of 2 integers. And if you have a look in here, you can see that, negative, square root 3, square root 3. If you find the answer, it will be something that is non-ending, non-terminating numbers here. You cannot make it to be the quotient of 2 integers. That's why, square root 3 is not rational number. So this is false. Number 4, sorry. Number, hang on. Yeah, number 4, sorry. Number 4, Warisa, false. Why is that? Oh, I'm sorry. I think next time I should bring some wireless. the number from square root can be both positive and negative. Square root, everyone, when you have square root, inside the square root must be positive. Okay, that is the first thing. Next, the result of square root always be positive. But you may say that okay, you saw some root that return negative like this. This one is possible because this is not square root. This is cube root. Cube root, the value inside can be negative because actually this one comes from and when you take the cube root out, you get negative 2 as the answer. This is possible. But square root, you have square root negative 4. This is imaginary number, not the root number anymore. So that means, remember that there are 3 things that can make the result be positive. First, square root. Second one, square. Third one, absolute value. Right. You have negative 4 squared. This one is okay. You get the answer 60. Okay, this is positive. Square root, absolute negative 4. You get 4 as the answer. Because the absolute value always gives positive answer. Okay. Right. But this one possible. But okay, now let's come back to this one. Square root is not a positive integer. When you take square root to 25, what is the result? Square root 25. Right? It is equal to 5 power 2 over 2. Positive 5. So it's not positive integer, it's false, not happening here. Next, 2 over 7 is rational or not? Hint. True. Why is that? It matches with your rational numbers definition, right? You can make it as a fraction of 2 integers divided to each other. And this is it. That's why 2 over 7 is rational number. True. Oh, hang on. 2 over 7. Is it rational? Go back to the definition again. Oh, okay, yeah. It is rational number, but anyway, that number is non-terminating repeating decimal numbers. Yeah, that's correct. I'm sorry. Next, 0 is not rational. Yeah. True or false? False. Why is that? Yeah, that's right. Can be divided by any integers except number 0. Okay, so 0 is rational number. So this is false. And the last one, is square root to a real number? True or false? True. Why is that? it will be the non-terminating decimal numbers นะครับ that is matching with the real number definition and it is and it is a real number. That's right. So this one is true นะครับ Okay, you did a good job. Now let's move on to the next slide. So this one นะครับ true or false as well นะครับ now I want you to do it นะครับ I give you 3 minutes to do it again and then I assign like some students to answer for this with your justification why it's true or false นะครับ Okay, time start now 3 minutes นะครับ let me just write down the name of the students ครับ Okay, time's up ครับ everyone. So Anya ครับ what is your answer? Is 0 over 0 is rational? Yes. Why is that? You're not sure? Because it can be divided by integer or it can be in form of integer divided by an integer, right? But do you remember I told you that for the real number, every number can be that can be the integer must not be the number that is divided by 0. Because when you divide any numbers by 0, it will become imaginary number. So this one is not rational นะครับ unfortunately. Next ครับ สุพนัท Is pi a positive integer? True, right? Why is that? .14 something. Is this one integer? 3.14 is the integer? It's the decimal. So if you want to claim that pi is a positive integer, you have to use this one ครับ Sorry. When you want to use, you may say that it's 22 over 7, but when you divide it, it's decimal number anyway. So pi is not positive integer นะครับ Positive integer must not have decimal points. Okay. So it's false, unfortunately ครับ Next on นะครับ ธนาทิพย์ครับ True. Every integer is positive or negative. Yeah. Okay. Next ครับ ยานิน True. Every natural number is an integer. Natural number start from what number ครับ Number 1. That's right. So because it is 1, 2, 3, and so on. That's why it's a real. It is the integer for natural number. So the next one ครับ Anchita. Okay ครับ True or false for some real numbers are irrational numbers. True. High pitch means that you're not sure, right? But actually it's correct. Why is that? For real numbers, there are 2 possible sets. Rational and rational or irrational. This one, when you talk about irrational numbers, some members of the real numbers are irrational numbers. That is true. Next, สหพัฒน์ครับ สหพัฒน์ True. Why is that ครับ Because it สามารถเขียนเป็นเศษส่วนได้ or can be written as a quotient, right? That's right ครับ every whole number is a rational number นะครับ Okay, that's correct. Next นะครับ Every integer is a natural number or not cognitive. False or true? Why is that,ครับ? Okay. So every integer is a natural number. Normally, a natural number starts from number 1, right? Onward, 1, 2, 3, 4, 5. It doesn't include 0. It doesn't include negative number. So some of the integers are negative or are 0. So that's why not all of the integer is the natural number. That's why this one is false, right? Okay. The last one, ครับปันทพล false. Every rational number is a whole number. Why is that? Because can you guess some ideas, some reasons to support? Yeah, that it is. That is the correct explanation, but you just like have to convert it to English only. Some of the whole numbers have some of the whole number is like start from what number? Whole number 0, 1, 2, 3, 4, 5, and so on, right? But rational numbers, some of them can be converted to 14 of integers. Some of them are non-terminated numbers, right? For example, if you set a 2 over 3, that is rational number, but it is not whole number. That's why this one is false. Okay. Any questions about these examples? All right. So if you don't have any questions for this slide, let me just like talk about the properties of real numbers. Because right now, all of us know about the what numbers are in the real numbers or are the real numbers already. Now let's see. These are properties of the real number. We say that the first property is closure property. Closure property is that when you do the addition, let me just like have this. It's a property's name. And when we do the addition and when we do multiplication, what does it mean by this property? Now let's talk about the closure property. When you add two real numbers together, a plus b, the answer is that it will return to a unique real number. Same as the multiplication, this changes one, a times b. It is a unique real number as well. It gives you a unique real number. What does it mean by unique real number? You get one answer. Okay. Sum of the calculation give you two different possible answers. But if you do addition or multiplication for real numbers, they always give you one unique real number as the answer. Next property is commutative. The commutative property is that when you add two numbers together, a plus b, the order doesn't matter. You can switch the order to be b plus a. You still get the same answer. Same as multiplication. When you multiply a times b, the answer you get will be equals to b times a. The order doesn't matter for the real numbers operation. So that means if you have 2 plus 3, you get it is equal to 3 plus 2, right? Okay, 5 equals to 1. Four times 5 equals to 5 times 4. order doesn't matter. You can just like add up to the same like this. Next, associative property. Somebody just use the nickname for associative property for change the group or changing the group. A plus B plus C equal to A plus B first and then B plus C. Intermediate result, when you just like add a group like this might be different, but final result they might be the same. Same as multiplication. This is the associative. Next. Identity property. For the identity property, addition and multiplication has different values. That makes the addition to become identity. For addition, the identity for addition is 0. You add 0 to any values, you get that value, right? Okay. In this one, a plus 0 equals to 0 plus a equals to a. For example, 5 plus 0 equals to 0 plus 5 equals to 5. Right? So you add 0 to anything, you get that value. Next, when it turns to multiplication, the value to make the multiplication to become identity is number 1. You multiply 1 to any real numbers, you get that. 7 times 1 equals to 1 times 7 equals to 7. Okay. You still get the same value, then add or you multiply. If you just like add by its identity or multiply by its identity. The next one, inverse. For the inverse property, how about the addition first? Its inverse is that value, and you have negatives both. A plus its inverse equals to its inverse plus A. And for the addition, for the inverse property, when you add that value with its inverse, you get 0 as the answer. For example, when we talk about 7, inverse of 7 is the inverse of number 7 is negative 7. Okay. If you add 7 with its inverse, okay, for just like switching the order for the commutative, it's about negative 7 plus 7. You get 0. This is the inverse. In terms of multiplication, for sure, you cannot just like divide by 0. So that means the inverse of the multiplication is 1 over that value, except 0. Okay. So that means if you have 9, the inverse in multiplication of 9 is inverse of multiplication of 9 is 1 over 9. If you multiply this value together, or you have commutative, just do the term elimination. 1 equals 4. For multiplication, the inverse. If you multiply that real number with its inverse, you get 1. For distributive property, you distribute the number into the parentheses. That means you distribute that number equally to every term inside. In this one, say that A A times B plus C equals to A B plus AC. Now let me just show you this one first. When you have to just like use the distributive property, you just have to distribute 3 to both of them. Then you get 3x plus 2 times 3. Or you get 3x plus 6. Okay. Or on the other way around, if you just like have that term, y plus 1 times 4. Distributive property, this is backward. You get 4y plus 1 times 4. You get 4y plus 4. Right? This is what we call distributive property. And lastly, transitive. It means that A equals to B, and B equals to C. Then the transitive is B here. It makes A equals to C. Okay. For example, if I say that, okay, if I say that x equals to y, and then y equals to z. For the transitive property here, it says that x equals to z, right? If x equals to 2, z will be equal to 2 as well. Okay, because x equals to z. Right? This is from the transitive properties. That when you have, let's say you have 3 variables, variable 1 equals to variable 2, variable 2 equals to variable 3. That means we can conclude that variable number 1 has the same value as variable 2. Okay, so this is like what we have got for the real number properties. Right. So now you learn for the properties in terms of addition and multiplication already. On the next class, we are going to talk about the subtraction and division properties for the real number. So up to this point, we have any questions coming in? All right. So if you don't have any questions, that's all for today. We meet each other in on next week today. All right. So you have a nice day. Take care and stay safe, everyone. See you next Tuesday. Bye-bye. So I'll start uploading the clips during this weekend. You see it on campus.